Jen Shoute, University of Alberta, Canada.
Nanotechnology is becoming a greater part of our everyday lives. And one of the materials that has enabled this is called silicon, which today makes up about 90% of the electronic industry. But it does have its limitations. It's rigid, it's brittle, and it takes temperatures as high as 1,000 degrees to build. So if you take your phone, yes, it's getting thinner and slicker, but the fear of breaking it and dropping it and breaking it also increases. Even EKGs are getting more portable, but because you need to encase the electronics, the wires still make it very inconvenient. What if you can turn that into a patch that sticks to your skin and sends signals of your blood or your heart wirelessly? And finally, rigid electronics also contributes negatively to emerging technology, like this small sensor, which takes up a tiny area. In order to increase that signal, you need a circuit as large as a 10-inch tablet. What if you can turn that into a single monolithic chip with the same material that I have wrapped around my finger? Well, these materials, you've already heard of it today, is called metal oxide semiconductors. And when they're made thin enough, they are low cost, flexible, and reliable. So the question you may ask is, why haven't they become more ubiquitous or have proliferated? Well, the problem with metal oxides is that competing materials and metal oxides haven't reached the kind of power output required to enable many of these technologies. And these includes devices that are in commercial production today. But what we did at the University of Alberta is by changing the way we build these devices, we were able to achieve for the first time silicon-like performance while still maintaining the metal oxide advantage. So if you can imagine an application that requires bending or distortion, you can put a metal oxide circuit directly on top of them. And because it conforms to the surface, you can see it flex in this case with a biomechanical sensor and even amplifying the signal at the same time. You can even start thinking about extracting energy directly from solar cells, and for many emerging technologies such as robotics or surgical arms, wrapping a metal oxide circuit can improve many of its features, including the precision of its movement. And it is biocompatible and safe for humans, and it is ready to be mass manufactured today at low cost. So with this newfound technology or newfound power of metal oxides, we can finally enter an era of flexible innovation. In fact, many of the technologies you hear about today can directly benefit from it. Can you think of any? Because together we can break down the wall of rigid electronics. Thank you.